function. The essence behind a function is that it takes an input and it returns an output. And the question is, what is the relationship between the input and the output? And we want to express the output in terms of the input. For instance, this function takes in 2 and it returns 4. That is, it gives us an output of 4. It takes in 3 and it outputs 6. It takes in 4 and it outputs 8. So what is the relationship between the output and the input? Here we see that the output is twice the value of the input. So the relationship is the output is 2 times 2, 2 times 3, 2 times 4. And these values are the input values. Let's look at an example using this same scenario. For instance, let's say we have a car. This car takes in gas and it returns distance as the output. Now our car takes in 2 liters of gas. It moves 4 miles. It takes in 3 liters of gas and it moves 6 miles. It takes in 4 liters of gas and it moves 8 miles. So again, we see that the relationship between the output and the input is that the output is twice the value of the input. In this case, the distance is twice the amount of gas. So we can write the relationship as the distance is 2 times 2, 2 times 3, 2 times 4. And these values here are the gas. So how do we write this in a simplified way? Here we have our car. Here we have the gas, and that's equal to distance. But remember, our distance could be expressed as 2 times the gas. Now, what if I say I want to write car using a symbol? So I am going to have F that represents my car. I'm going to leave gas, and that's equal to distance, which is 2 times gas. But I am interested in this part. So now if I say let gas is equal to X, then my equation now becomes F, and this is X, and this now becomes 2 times X. So here we can see that how we have converted our real life situation into symbols. And how do we read this? This is basically saying F of X is equal to 2 times X. And this here, this F is here, this F is the car, and this X is our gas. It's the same thing that our previous example is saying. Now when X is equal to 2, that is gas is equal to 2 liters, our car now moves f of 2 is equal to 2 times 2, and that gives us 4 miles. When x is equal to 3, we have f of 3 is equal to 2 times 3, and that is 6 miles. A function could be of different forms. I am going to use a different example. Let's say we have a fast car. Let's say it's a Subaru car. So this is S car. It also takes in gas, and it returns distance. So in this case, we put in 2 liters of gas. Our Subaru moves 6 miles. We put in 3 liters of gas. Our Subaru moves 9 miles. We put in 4 liters of gas. Our Subaru moves 12 miles. Now we can see that the relationship between the distance and the amount of gas is that the distance is 3 times the amount of gas. So here we have 3 times 2, 3 times 3, 3 times 4, and this is the amount of gas. So to simplify it, we have S car takes in gas and gives us distance. And remember, our distance is 3 times gas. So let us call S car G. So this is G, gas, is equal to, and I am interested in this section. So this is 3 times gas. As before, let gas is equal to x. So now we have G of x is equal to 3 times x. So we have another equation here. Is a different function from before, but this time our Subaru car is moving 3 times the amount of gas that we put in. So when x is equal to 2, our Subaru car is G of 2 is equal to 3 times 2, and that gives us 6. When x is equal to 3, our Subaru car moves G of 3 is equal to 3 times 3. That's equal to 9. So we see how we can represent real life situation in terms of function, and that's essentially what a function is. In the next class, we look at more examples on functions. So thanks for watching.